8.4 happens to be compound interest. So, what is compound interest? Compound interest is interest where you gain interest on your interest. So you're gaining interest on a certain time period. So I could be getting that interest once a month. They calculate it, they put it in your account once a month. So then every month you're gaining that interest, but like on month 2, you get to gain interest on the interest. So you're gaining more and more money, as that account gets more and more money in it. Whereas simple is a one-time amount of money that you get at a certain time. So we can pay out every single day. We could give you interest. That's called daily. We could do it quarterly, 4 times a year. We could do it monthly, bi-weekly, right? We could do it a lot of different ways. So that's the idea of compound interest. So definitely a different formula brings in some exponents in our formulas. So look at this first section here. We are saying compound interest is interest computed on the original principal as well as your accumulated interest. To calculate the compound interest paid once a year, we use this formula. So I want you to make a note that this is once a year, and this formula we don't use much. So how do I want to say this? We used a little, I don't know. This formula down here is what I want you to put in your notes. Okay, so this first one, I wish they didn't do it, but the book does it and a lot of the homework does it, so I want to make sure I covered it as well. So let's go through what each of these mean here. The P represents principal amount of money. So it's, again, your starting amount of money. So P is always the same. Even if I am purchasing something, it's that purchase amount as well. And if it's a savings, it's how much I start with. 1, the number 1, plus the rate, always put it as a decimal for your rate, to the power of time. Now look down here, the difference is this in value. The in value represents the number of times per year that you're compounding. So up here, if we compound once a year, it would be a 1 there. So that's why they don't write it, is because the 1 doesn't affect it. Well, I'd rather you write the 1 than forget it for like monthly or quarterly or something else. So N is just the number of compounds per year. And I gave a big old chart down here for most of them. Okay, for daily, they might use a banker's year too. They just round each month to 30 days. So banker's year. All right. Future value is still our A, what we're going to have later, right? Everything else is the same. So let's look at problem 1. You deposit $2,000 into a savings account at Hometown Bank, and it has a rate of 6%. Find the amount of money in the account after 3 years subject to compound interest. So we're going to have our future value is equal to, we're starting with how much money? $2,000 times 1 plus my rate is 6%. How do I write my 6%? 0.06, right? Divided by a 1, doesn't really matter, right? 1 times my years. Everything's always in years. So if I said 4 months, you would do 4/12. Okay, so this is our formula. Do I need the 1 times 3? Do I need to divide by the 1? No, I could skip it like they did here. I'm just showing you the way that I want you to kind of remember it. So in your calculator, be careful the way that you put in this exponent here. Make sure it's in the exponent if you do the times. 3 times 1 is 3, so it's pretty easy to do. But if it was like, 360 times 12, you could put that in the calculator like that. You just need a parenthesis. So I get $2,382.03. This is our total amount of money. Be careful on your rounding too. Some of them tell you to round up regardless of what the problem is. So just read the way they want your answer. All right, well, how much interest did I gain if I started with 2,000 at the end of this 3 years? To find the interest, you take your future value and you subtract off your original principal, and that's going to give us $382.03. That was our interest amount. Okay, so let's do some harder problems that are including this different compounds. So problem 2, I'm going to deposit 7,500 into a savings account that has a rate of still 6% compounded monthly. How much will I have at the end of 5 years? So let's do part A. So we know our future value is what we're looking for. And we start with 7,500, parenthesis 1 plus our rate is still 6%. So we have to write that as 0.06 divided by how many times are we compounding it per year? Well, it's compounded monthly. How many months are in a year? 12. If I was doing weekly, how many weeks are in a year? 52. Okay, so forth. Then in your exponent, you have 12 times the years. So how many years? 5 years? And again, use a parenthesis in the calculator there. So 7,500 in my calculator, parenthesis 1 plus 0.06 divided by 12 to the power of parenthesis 12 times 5. Some of the newer graphing calculators will stay in that exponent spot for you, so you don't need the parenthesis, but the older ones do. And your scientific ones do as well, 38. All right, so at the end of 5 years, I'm going to have $10,116.38. Okay, part B, how do I find my interest? So if my future value is 10 grand, right? So $10,116.38. If I subtract my starting amount, that's my interest. So I haven't touched the account. So I get $2,616.38. That's a lot of interest. I gained a couple thousand, almost $3,000 in interest. Okay, for some banks, continuous compound, where compounding periods increase indefinitely. So what if I want to try to compound as much as I possibly can? So I don't even want to do it daily. I want to do it every hour of every day, every second, like as much as I can. That's where compound continuous formula comes in. Now, we don't focus on this one as much as you do in, like, if you take the upper vision business math classes, but this is our formula for compound continuous. Sure, it was me yawning. Most of what you're going to do is compound monthly, yearly, daily, weekly, whatever else. Quarterly is a big one. But let's go ahead and figure this out. After T years, the balance A and the principals, which is the form, is given by the following. Oh, this is just the formula. Okay, and what does the E represent? So the E is a key on your calculator, usually by your natural log. Here's a natural log right here, and you can see it above. And I have to do like the second hand key. I don't have where my little one over there? My little, I have a, there it is. I'll show you on this one too. So on the little pink calculator that I have, the log buttons up here, this is just a common one that people have, log buttons up here. And this one's a pretty good one for doing these because the screen's still big enough to see most of your formula. So this one is yuck, but it's an old Texas Instrument. And again, above the log, we have that E key. So E is just a number. So you can put in, you know, your E don't know why I'm using the calculator. I don't know where to find anything, but to the 1, and you can see the E is just like pi. It's like 2.71 something. So 1828. So it's just a number that actually is just estimating that compounding continuous all the time. So E is just a number. Okay, so let's do an example here with E. You decide to invest $8,000 for 6 years. You have a choice between two accounts. The first pays 7% compounded monthly, and the second is this little bit lower rate, but compounded continuously. So one is compounding per year for a lower or higher rate, and one is, so now we get to see how big of a role that rate really plays. So for the first one, it's compounded monthly. We're going to have our A equals, how much are we starting with? 8,000. 1 plus our rate of 7%. Compounded monthly means a 12. Okay, 12 to the power of 6 years. So compounded continuous is going to be this new formula. A equals principal amount, still 8,000. This new E to the rate. Now our rate, you got to move your decimal, 0.685 times that same amount of years, which is 6. So these are our two formulas. Now let's put those into your calculator. So 8,000, 1 plus 0.07 divided by 12. Take the time to put this into your calculator, because this is where most people make mistakes. If they're not getting the right answer in their calculator, then you're not going to get the right answer on the exams or your homework. So make sure you can get my $12,160. Now, 8,000 times, I got to do secondhand E, got the E to come up, and then 0.0685 times 6, all in the exponent, and then enter. I get $12,066.60. So monthly is still more money that you gained with that interest rate being a slight more. So interest rates are huge. Compounding does make a difference. You want it to compound as much as you can, but a slight increase in interest rate is going to make that bigger. So pays this much you want to invest. So which one should I go with? This one makes more money. Better deal. Okay, better interest rate, better deal. Now, if I was paying it, I want the other one because I want a lower rate. Okay. Now, what is this present value thing that they're doing? Well, they took the formula for you and they solved for P. Because our formula, if you look up here, is right here, right? So here's our formula. If I solve for P, I'm dividing this over here, and that's all they're doing here. They're dividing for you. So some people get confused that they need to write down all these formulas. That's the same formula. They're just solving for P for you in case you want to find that principal. So what if I have like a goal amount of money? I can see how much I need now to put away for that goal. So if I want $1 million to retire with, how much money do I need to put in my account right now to get to that goal of $1 million? That's this type of problem. So example 4, how much money should be deposited in an account today? So it should be talking about now to get a future value, that A value. And all this money. So let's do that so we can still see that. So this formula is going to be P equals, our goal is $20,000. And we have 1 plus our 6% rate. And this is compounded monthly. So N is 12 to the power of N times 5. Oops, 12 times 5. We know N, 12 times 5. Again, parenthesis here. Now, to do this in the calculator, You might want to do the denominator numerator separate and then divide them, or use a parenthesis, big parenthesis. Just be careful. So I'm going to put in 20,000. Let me clear this whole thing. So I'm going to put in the 20,000 divided by a big parenthesis and a second parenthesis for 1 plus 0.06 divided by 12 to the power of 12 times 5, and then end the parenthesis in order to get the amount. So I'm like doing a double parenthesis in there. I can't see the whole formula there, but okay, so let me do it this way, secondhand. You still can't see the whole thing. It's all right. So I got $14,827.44. That's the amount of money I need now to get to $20,000. And it might make you round up on these problems. I'm going to go ahead and do it. I had a 3, but I'm rounding up because you can't actually get to that amount. I mean, even though it's only 0.3, you're not going to actually get to the right amount without 1 more cent being included. Okay. So these are all of our compound interest formulas. Hopefully you can get them to go into your calculator correctly. That's going to be your biggest thing. You will still get a note sheet, so you can still write these all out on your note sheet to make sure you don't have to memorize anything. Okay, the effective annual yield. I shouldn't say you don't have to memorize anything. You should understand what they mean. You have to memorize some things, right? You just don't have to memorize the exact formula. Okay, effective annual yield. How am I going to compare my rates? So let's say I have this option for a CD over here with simple interest. I have this option over here where I'm investing in stocks and bonds. And then over here, I have this option of a savings account. What should I put my money in? How do I know? How can I figure out what is the best? Well, this is one of the ways, is this effective annual yield. It will tell you what percent you're actually getting if it was simple, okay? If it was simple. So they say effective annual is the simple interest rate that produces the same amount of money. So it's a way to compare. So it's going to bring everything to that simple. So it's going to bring everything to that simple. So let's look at a problem. It says down here, you deposit $4,000 in an account that pays 8% compounded monthly. Determine, I'm going to skip A, just determine your effective annual yield. So our yield is going to equal 1 plus our rate of 8% divided by our compounds, which is monthly, to the power of monthly minus 1. Okay, so let's put that in our calculator. Parenthesis 1, plus 0.08 divided by 12 and to the 12th power, and then a minus 1 is going to give me a rate of 0.083. It's like 0.29999. So about 8.3%. Okay. 6 says, what if change this monthly here to yearly? Yeah, because we don't want months again. All right, determine the effective annual yield. We would have the 1 plus that same rate yearly. Do we want to use the banker's year? I don't know, sure, 360 or 365. If you miss a problem because of that, you can just shoot me that ask the instructor and I'll give you the point on that. Unless it clearly says use the banker's year, and then you have to use 360. Okay, and then this is to the power of 360 because this is compounded daily. Oh, I said yearly. I meant daily. Did I confuse you? Sorry. Yearly's 1. That's lame. daily. Duh. All right. And one we haven't used yet is all I wanted to do. And then -1. Because we haven't used daily. We haven't done quarterly either, which is a 4. A lot of these problems have monthly. Why? Because monthly is the most common. Okay, so we're going to do daily, not yearly. Plus 0.08 divided by a year, 360 to the power of 360. And then you have your -1. And I get 0.083. Ooh. The other one was 2.9999. This is 3.3. And then this one was 0.082999 or something like that, just because it's hard to compare. So look at how close your rate is on this one. I mean, really close. But which one is a higher yield? It would be daily because it's got more compounds. It should be higher, but by much, no. So compounding every day, putting money into that account every single day, your interest in, is pretty close to the same as monthly. Except if you're the banker trying to calculate that every day, it's a pain. Okay. A passbook savings account has a nominal rate of 5%. The interest is compounded. Find the annual yield. This was just an effective annual yield. I think we're good. I did too. Okay. So this one isn't as common as all the other parts of this, but it is great to know a way to compare your rates. Okay. All right. I don't have a mouse to turn this off.